Okay. Perfect. Abby's ready. Gwen's ready. So it needs to be open. I already asked you to open it, so let's get started. Okay. So we're looking at our learning targets for the day. Our learning targets are, I can explain the meaning of the term constraint. We're going to be introduced to that in a minute. I mean, actually not in a minute, in about probably 10 minutes. I can tell which quantities in a situation can vary and which ones cannot. And I can use letters and numbers to write expressions representing the quantities in a situation. Okay? So if we look at our warm-up for the day, it's called a main dish and some side dishes. Here are some letters and what they represent. All costs are in dollars. So M, in these equations down here, in these expressions, M represents the cost of a main dish. N represents the number of side dishes that they buy. S represents the cost of a side dish. And T represents the total cost for the meal. Okay? So all of these variables are defined by what they mean here. Okay? Because later on you will be asked to define what each of these means. Let me just turn my ink on. Sorry, guys. And you will be asked to identify what they mean. And that is what it's going to look like on yours. Okay. So once we look at this, you're going to take 2 minutes right now to think about and write down what does each equation mean in this situation. So when you look at M is equal to 750, using what we know about that value, what M represents, I want you to tell me what that expression or this equation means. Then I want you to look at these other ones, use these variables up here to explain what each of these statements means. You're taking a minute and a half right now to identify what each of those equations and expressions represents in the story, okay? So you guys can get started. A minute and a half. There we go. Is an expert. Well, not really. Nice job, Max. Okay, we are taking 21 more seconds for ourselves. What do each of these equations represent? And these are all equations because they have an equal sign. Two expressions equal to one another. Nice job, Gabe. Okay, and let's get started. Let's take a look at this. Sorry about that. I just need to grab my paper. Okay. So let's take a look at what this means, what this represents here. Okay. So each one of these, this one, as Gabe said, a main dish costs $7.50 because M represents the cost of a main dish. A main dish costs $7.50. Very good. Nice job on that one, Gabe. Nice job, Kyle. That's a good way to sort of flip-flop it and say it a different way. Max said for number 2 that a side dish costs $3. Okay, so Max substituted in this $7.50 for M, but that's not exactly what it was asking you to do. It didn't ask you to substitute in that 750. We're just looking at it more broadly. So we could say that a main dish is equal to, or a main dish's cost is equal to what? What is it equal to? A main dish's cost is equal to what? Nice job, Max. A side dish plus 450. Very good. And I like that Max actually took those numbers from the previous ones and sort of plugged them in. That wasn't exactly what it was asking, but Max, that was really smart. Nice job. So yes, it is the M is equal to 750, but you weren't asked to take it and plug those values in. It was asking you to just look at that equation and tell me what does it mean just with the letters in it, okay? So now if we're looking at the third one, NS is equal to 6. What does NS mean? Abby, what do you think NS means? The number of side dishes. So the number of side dishes, so good. But what operation is happening there? Because N represents the number of side dishes, but what does the S represent? And what operation is going on there? Abby, unmute yourself for a second. I want to have a chat with you about it, okay?
Would it be like the number of side dishes times the sides?
Times the S represents the cost of a side dish. So it's the number of side dishes times the cost per side dish is equal to $6. That's what that one's trying to say. So when there's no sign here, that you can say it's multiplication. So this one would be equal to the number of sides times the cost times the cost per side is equal to 6. Okay, so that is what that statement means. Get that copy down if you don't have that copy down for yourself, because you need to talk about both pieces of it, because it's N times S, so the number of side dishes times the cost per side dish is going to be equal to 6. So then Max said that this last one is talking about the total cost. So what does the total cost include? Kyle said the meal cost and the main dish plus the side dish with the cost is equal to the total cost. So what this is saying, this last piece is putting everything together. I know what you meant there, Kyle. So what this last one here is saying is it's saying the main dish plus what? The main dish plus what? What did we say that NS stood for? Ian, help me out. Unmute and let me know. What does that NS stand for?
The number of side dishes times the cost of the side dishes.
Very good. So the main dish plus the number of sides times the cost per side is equal to the total cost. Okay, listen, I understand that this is a very wordy and there's a lot going on here, but we need to be able to understand and identify what each of these variables represents, because you are actually going to be writing expressions and equations like this today. So I'm going to erase this piece right here. I'm going to leave this piece written right here so that you can copy it down as I move on to the next piece of this, okay? Okay, so let's take a look. You're copying down if you didn't get a chance to finish. Here are some letters and what they represent. All costs are in dollars. Write a new equation that could be true in this situation. So we have 4 here. I want you to come up with any other one more expression or equation that can be true using these variables. I want you to take 1 minute right now to write another equation that can be true based on these variables. Anything you might want to write. Then tell me in the chat the expression that you write or the equation. Nice job. Nice job, Max. Let me see these in the chat once you guys are answering. Is it okay if I delete is it okay if I erase the bottom here? Is anybody still copying? Let me know if you're still copying. Okay. Okay, perfect. Thanks, Kyle. Okay. Fantastic. We're taking 6 more seconds. Okay, awesome. So I got 1, 2, 3, 4 friends that gave me expressions and equations. I need 3 more people to put their expressions or equations in the chat. I'm going to start to write a few of them down. So Max gave us one of 1350 is equal to, and then he took that last one, n times s. I put the little multiplication sign so that you knew. Plus n. That's fantastic, Max. That's perfect. Fantastic. He substituted a value in for that t total cost. Very good. So, Kyle, the thing about that one is that is exactly the same as the last one, so it's not really a new one. Okay. Oh, Gwen, I love it. T minus m is equal to n times s. Woo! Yes, the total minus the main dish is equal to the number of sides times the cost per slide. Woo! Side, very good, nice job. Ian said m is equal to s plus 550. That's fantastic, nice job. That's a really good one. Now, Gabe said that 5m, or 5 times the main dish, so 5 main dishes, is equal to 3750. I would just say make sure that you write a dollar sign in there for yourself, Gabe, just to remember that you are talking about moolah there. Moolah, moolah. Okay, Abby said n times s is equal to $10. Fantastic. Those are all really good. If you took any of those equations that we wrote on that last slide and you substituted a number in, that can work. Or you can sort of run it like Gwen did, where she sort of rearranged them and gave an equivalent equation, because this one is equivalent to that last one on the last slide. Awesome job. Fantastic. Okay, last piece here we're going to look at. Can equations contain only numbers? Yes or no? Let me know in the chat. Can equations contain only numbers? Okay, we're going to talk about equations in a minute, what an equation is. So an equation is 2 expressions or 2 quantities, right, set equal to one another with an equal sign. So you could have 34 is equal to 34. You could say 34x is equal to 34x. You could say x is equal to x. These are all equations. The main piece that an equation needs to have is you need to have 2 quantities, 2 pieces, 2 terms set equal to one another. So if you have two things that are set equal to one another with an equal sign, you have an expression. You have an equation, I'm sorry. So if you have an equal sign and the two quantities are in fact equal, then you have an equation written down. So can equations contain only numbers? Yes. An example of that could be, what could be an example of an equation that contains only numbers? Let me see in the chat. What's an example? You're missing the most important piece though, Gabe. I said an equation needs to have an equal sign. You have to have two quantities that are equal to one another. Very good, Gabe. Nice correction there. You said 11 plus 2 is equal to 13. Fantastic. But does this contain only, oh yes, this does contain only numbers. Perfect. Abby said 5 is equal to 5. Fantastic. Gwen said 5 plus 2, 7. Very good. These are 3 examples of, nice job, Naseem, nice job, Junior, as well. This is an example. These are examples of equations that contain only numbers. Good. Now, as we look at this next one, can an equation contain only letters? This one is also true. An equation can contain only letters. What is an example of an equation that contains only letters? Nice job, Gwen. Gabe, that's fantastic. Y equals mx plus b. Very good. Gwen said x is equal to x. Fantastic. Abby said x plus y is equal to z. Fantastic. Nice job, Abby. And then Junior said x plus x is equal to 2x. Oh my goodness, I love that one. But we're only containing letters. So that one would be a good one for this one here, Junior. So that one would fit better in here because it contains numbers and letters. X plus x is equal to 2x. Another example could be V equals, and then we could say V is equal to length times width times height. Boom. Okay, so then if we look at this last one, can an equation contain a mixture of numbers and letters? If it can contain only letters and can contain only numbers, then we can say yes to this guy as well. What is another example than the one that Junior gave us? Kyle gave us one. 2x plus 3, or 3x plus 2x is equal to 5x. Nice job there, Kyle. Junior's was really good too. Gwen said 2x is equal to 2x. Fantastic. Nice job. Sadie said, this is a good one, Sadie. Y is equal to 14 plus 3. Fantastic. Awesome job, Sadie. I haven't heard from you yet today. I love it. Fantastic. Keep it up. Gabe's is also really good. 10 is equal to 5x. Very good. So equations can contain only numbers, equations can contain only letters, and it can contain a mixture. The most important piece is that you have an equal sign. If you just have 34x and it's not equal to anything, or if you say 34x plus 2, that is not an equation, that is an expression. It is 1/2 of the equals. If there's no equal sign and then another quantity on the other side, it's not going to be able to be called an equation, okay? Awesome job, Elliot. That's a good one. Nice job, my friend. Let's take a look at the next piece here. I'm sorry, I spent a little bit too much time on this, but it was a good discussion to have, okay? So we are going to skip this last question right here. We're going to skip this last question right here, and we're going to move into the activity for today / this afternoon. So today / this afternoon is going to run a little bit different. You are going to have the rest of class today to get started on everything. And I also can put in a video on slide number 7 that goes through the last bit of all of this information. because I wasn't sure how much you were going to get done in class, I want to give you some independent work time. I created a video going through the whole thing. Okay, the video link is not an Edpuzzle video today because I don't want you to have to sit and watch the whole 15 minutes if you're only working on one part of it. Does that make sense? I don't want you to have to watch the whole video to get to like 5 minutes in. So I was a little bit, I was looking at it, I was thinking about it last night, like I was sleeping and I was like, I woke up and I was like, I really shouldn't make it an Edpuzzle video because it's not really fair to make them watch everything. So let's take a look at what you're gonna be doing today and then for this afternoon as well, okay? So it says, imagine your class is having a pizza party. We're having a pizza party, okay? Some point before our midterm, we're having, well, it's not gonna be like during school. It's gonna be like an after school pizza party. We will actually be having a pizza party. I'm telling you right now, where we're gonna be eating pizza and studying for the midterm. Work with, so you're working independently to plan what to order and to estimate what the party would cost. So you're gonna record your plan and estimated cost on slide number 9. So let me show you what that's gonna look like. So you're gonna use, at the bottom here, you have a menu, okay? And I just picked a menu for a restaurant in town. A pizza place in town, like so this is slice and you just go through and you pick what you want to order. But we need to sort of have a little bit of a discussion before, so you can obviously close that out. And then the menu is here. It's kind of a really big menu, so you can just go through and like pick what you want. But let me tell you what you're doing with this. Okay, so you're going through and you're planning a pizza party for our class, but you're not just picking willy-nilly what you want. We need to be strategic in the way that we're planning this. So if you look at the, I also put in a calculator here for you so that you can more easily get your cost all totaled, okay? So on this slide right here, I put in 2 fake items. So all of these items that I put in are in yellow. Okay, and I put those in just so like you have a reference of like something that you could have bought, right? So you buy a pepperoni pizza. So you talk about, first you want to talk about the number of students in class. So how many students do we have in our class? 19 plus, do you think I should eat some pizza? I personally love pizza. Yes, Kyle's is sure. So the number of students in class, right? If we're going to talk about how many people are going to get this pizza, we're talking about ordering for 20 people, okay? So I want you to, so it's, no, it's 19. It's 19 with everybody, I promise. Everybody's not here today, so that's why we were missing one friend. So it's going to be 20. So the number of people in class is going to be 20. And so you're going to use that number to plan a pizza party, okay? I want you to think about how many cheese pizzas are you getting? How many pepperoni pizzas are you going to get? Are you getting like a salad or some mozzarella sticks? Because I personally love mozzarella sticks. And so you're talking about the item that you're buying, the cost per item, the number that you're planning on buying, and the total cost of the, and the total cost for however many you buy, okay? And once you do that, you're gonna try to calculate the cost per person. So using that, like in theory, how much would it cost? But I'm not, like when we have our pizza party, you're not gonna be paying. And then once you have your pizza party planned, you're going to come onto the next slide, slide number 10, and you're going to write down one or more equations or expressions for the pizza party that we're having. So I wrote some equations here. If you watch that video, I actually write some expressions as well. So an expression could be 1299p. 699p. So you're going to be writing an equation for your total cost, right? And then the expressions for each piece of it, right? So when you're talking about the pizza, you're going to say $12.99 times P, the number of pizzas that you're buying. $6.99 M, so it's $6.99 times the number of mozzarella sticks that you're buying. So you're going to write out your equations and expressions, identifying what each of the variables represents. Does that make sense? So I want you to get started right now. I want you to take the last 10 minutes of class right now to get started on planning your pizza party. And then if you finish, you can start to write your expressions. And then for the last bit of it, I want you to watch that video to go through whatever you don't get done. Okay? Does that make sense? This afternoon, when you're working at home, this afternoon, I want you to take 25 minutes tops to work on this. If it's taking you longer than 25 minutes, cut it off and you're good for the day. Okay? So you guys can get started to plan your pizza party. I would suggest keeping the my yellows in there until the end, because I use these same examples of pizzas and mozzie sticks throughout to give you explanations of what you need to do, okay? Does that make sense? So these examples are in it moving all the way through. Okay, so I want you to get started, and I want you to reach out to me if you have any questions, like in the chat, send me a chat. Before the video. So the video starts with, so the video, if you look at it, I go through I start from here and I go through all the directions all the way down. So I go through exactly what I just talked about in class for these slides, and I go into constraints and models. So you don't need to start watching the video right now, because it just explains what I said here. And you can just skip past that when you watch the video later. Does that make sense? I just wanted to make sure that if the warm-up took the whole time, you had a video of, no, you don't have to do slide 6. Sorry, no, you don't have to do slide 6, guys. If anybody is unsure of what they need to do, throw a question for me in the chat and I can help you out. No. So if you just want to buy like 2 things, that's fine. If you want to insert more rows, like if you're going through and you need more spaces here, you can click right in one of the rows, right click or like 2-finger click on your mouse pad, and you can go like, so double 2-finger click, and I don't know why it's not letting me insert another row here. Oh, yeah, okay. So then it says insert row below, and it'll throw another one in. So the pizza, the pepperoni pizza and the mozzarella sticks is, I'm not sure if those prices are right. I just put in random numbers for those. So these might not be right. If you want to use pepperoni pizza and mozzarella sticks, I would just go back to that menu and check the price again, because I just sort of pulled those out of the air just as sort of practice samples. 1 second. Yes. You have to do all the slides from 7 through, so 7 through, oh goodness, 18. But there's a video that goes along with it, okay? Or are you saying, what do we have to do? Or are you saying, do we have to do all the slides? I just don't get what you're saying, Kyle. So I sort of pulled pepperoni pizza like out of the air. So there might not be like an explicit like pepperoni pizza. You might have to do something a little bit like if you look at the, so you're going to the pizzas, right? So I don't really care. It's not a big deal. No, Mr. Maine, why are you such a stinker? So when you look at your pizzas here, so like a mozzarella cheese pizza would be like obviously like your cheese pizza. And then you sort of just are going to look through these different ideas here. So I would say like this hometown special pizza with everything, you could like buy this and then like have them take off the whatever you don't want. So you could just say like hometown special pizza, and then that could be your pepperoni. And then you can just have them put the pepperoni on. Like you might have to be a little bit creative, but I mean, you know, creativity. Oh, perfect. Okay, perfect. So just like Max just said, so when you go here and then you click on, Gwen, if you click on the mozzarella pizza, you can add toppings to it and it'll give you a new price. Oh, that's so smart. Thanks, Max. You're so good. So if you go to like this mozzarella, so like you click on this baby right here. Oh my goodness, Mr. Maine. And then you can, if you like, it's thinking, and then you can pick the size that you want, and then you can add pepperoni, the ronesies, the ronies, and then if you go like a medium, you could get like, and then it would have the price, right? And then if you say, so it would be $12.45 plus the $1, so it'd be like add to the cart. My suggestion is maybe like do it and like add it to the cart so that you have your total with everything that you want. Yeah. Oh, perfect. Look at that, Max. You're so good. See, mozzie sticks. Oh, I was wrong in the price. But I could always go for a mozzarella stick. But like, don't get too hung up on like picking the perfect pizza party pizza. Like, just pick a few things and move forward, okay? I mean, no, I'm not saying like, I'm just saying you don't have to get too hung up on it. Okay, so ladies and gentlemen, we are at the end of time for today. So like I said, this afternoon, what I need from you is I need you to give me 25 to 30 minutes this afternoon of working on this and getting through as many of those slides as possible. Once you get past the planning, the pizza planning part, it goes pretty fast for yourself, okay? So you're going in, you need to get through all the way until the warm up the cool down. And if you don't get to the cool down, that's okay. I need you to get through at least 16, but don't spend more than like 35 minutes on this afternoon, okay? I'm going to stop sharing. I am going to